Hello, good morning, good afternoon, or good evening, ladies and gentlemen, and thank you for joining us for yet again another ecology video. So today, what we're going to be talking about are biogeochemical cycles, or more importantly, how minerals and elements get recycled through an ecosystem. Today we're going to be talking about a few different ones, including the hydrologic cycle, the carbon cycle, nitrogen cycle, and phosphorus cycle. So let's get started. So biogeochemical cycles, that primarily is just matter moving through the environment. Every living thing needs certain elements or compounds for life processes, or to sustain life. These elements include things like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And remember that matter is recycled through an ecosystem. It is not a one-way flow. So matter is not created, it is changed from one property to another. The long story short is we're not creating these things, we're just changing them and recycling them throughout the process. So like we said, the cycles we're going to cover are the water, carbon, nitrogen, and phosphorus cycles. So let's start off with one that everybody knows. That's the water cycle. Or if you don't know it, hey, no better time to go ahead and learn. So the water cycle, this is referring to all of the water on the planet. So water can be found in things like lakes, streams, and the ocean. And through the process of evaporation, it goes from a liquid state to a gas state and floats up into the atmosphere. This can also occur through the process of transpiration. Transpiration is just a fancy term for tree sweat. That is water leaving through leaves of a plant. Once it goes ahead and pools up in the atmosphere, it begins to condense, called condensation. These are what you go ahead and see in storm clouds. This water goes ahead and then turns into precipitation, so things like rain or snowfall. From here, it can go a few places. It can go ahead and hit the surface of the land and fall back into the bodies of water. Or it can go ahead and be absorbed into the ground through the process of percolation. From there, it goes ahead and adds to the groundwater and eventually can make its way back to the ocean. So it's one big cycle of evaporation, transpiration, condensation, and precipitation. Next up, let's talk about the carbon cycle. So carbon in the atmosphere. Carbon moves through the atmosphere and food webs on its way to and from the ocean, sediments, and rocks. Sediments and rocks are the main reservoir of carbon, at least, on the planet. Atmospheric carbon is mainly carbon dioxide, or what we exhale every time we breathe, or speak for that matter. So anytime that happens, carbon dioxide is added to the atmosphere. So, with that, carbon is important because carbon is one of the most fundamental elements found in living things. And as such, we need carbon to survive. That's why you might have heard, some people, at least in sci-fi movies, refer to things on Earth as carbon-based life forms, because carbon is incredibly important. So things that can go ahead and add carbon dioxide into the atmosphere include things like aerobic respiration, breathing, volcanic action, burning fossil fuels, decomposition of organic material, and the production of waste products, all of which can go ahead and add carbon back into the atmosphere or return it back to the soil. This adds to what we call the greenhouse effect. So the greenhouse effect, mainly there are going to be holes in the ozone layer, which cause the sunlight to go ahead and be absorbed by our planet a bit more easy, causing the general temperature of the planet to increase over time. And these greenhouse gases, such as carbon dioxide, are removed through the process of photosynthesis via plants. So the carbon cycle, like we said, this shows you just a brief overview of how carbon can enter the soil as well as the atmosphere. So if you want to go ahead and pause it, take a little look there, be my guest. The nitrogen cycle. Nitrogen is used in amino acids and nucleic acids. All living organisms need nitrogen to make protein, so this is what's found inside your DNA. That's kind of important. The main reservoir is the nitrogen gas in the atmosphere, roughly 78% of our air. Decomposers, such as bacteria and fungi, are incredibly important because they go through a process called nitrogen fixation. What that does is that converts unusable forms of nitrogen into usable forms for plants and animals. So, that is important because if not for these bacteria and fungi, plants wouldn't be able to go ahead and get their nitrogen. And this nitrogen flows through the food web, traveling from organism to organism. So, simply put, without these small little microbes, we wouldn't be able to go ahead and reproduce our DNA, make new proteins, or new cells for that matter. So, same thing, if you want to go ahead and pause here and take a look at the various steps in the nitrogen cycle, feel free. Also, denitrification. That is when bacteria releases the nitrogen in dead organisms back up into the air, recycling the nitrogen back up into the atmosphere. Finally, we're going to talk about the phosphorus cycle. Phosphorus is part of phospholipids in all nucleotides. So, once again, talking about DNA, RNA. And the main reservoir is the Earth's crust. It has no gaseous phase. So, phosphorus can be found in the soil, inside organisms and animals, as well as in sedimentary rock. Same thing, if you'd like to go ahead and take a look at that, feel free. And with that, ladies and gentlemen, this is a bit of a short video. We're going to go ahead and close things up here. Thank you very much for your time. And remember, if you have any questions, please feel free to go ahead and contact your teacher. They will point you in the right direction and help remove any confusion you may have. So with that, once again, thank you very much for joining us today. And until the next video, you take care, and I'll see you.